Okay, so this was what I was trying to do. And from question 3a, so the derivative of this is going to be 6x squared plus 6x minus 72. So if we want to find the maximum or minimum, you know that you have to equal this to 0 and then factor, right? So we can factor out 6, and we're going to get x squared plus x minus 12 equals 0. And this is the same as 6 times x minus 3 times x plus 4. Okay, so your critical points are going to be -4 and 3. So what we've done so far is that we make a table of values with -4 and 3, and then you test values before -4, like -5, in the derivative. And if you do that, you're going to get something positive. Between -4 and 3, you're going to get something negative, and then you're going to get something positive after 3. So what that implies is that it's going up, then coming down, then going back up. So this is a way of saying, well, this has to be a maximum and this has to be a minimum. But the other way you can do it is using the concavity test with these values. So how do you do the concavity test? You do the second derivative. So the second derivative is just the derivative of this, right? So the second derivative is going to be 12x minus 6. So don't equal it to 0 because we're not trying to find the inflection points, but rather we want to plug in these values to see if we get something positive or negative. So notice that if you plug in 3, you're going to get 36 minus 6, and that's 30, which is positive. So that means that the concavity is upward. And then if you do the same with -4, you're obviously going to get a negative value. So, oh, this was +6, by the way, not -6. But it doesn't matter, it doesn't change a thing. This will still be positive and this will still be negative. So this is going to go downward. So that means that at -4 you have a maximum and at 3 you have a minimum. That's what I was trying to say.